Welcome everyone. Okay, so let's see if we can get started here. I think do I have to share my screen in any way? I'm not sure. Interesting. Whoa. Okay, so that's my background. I'm not sure how I send this up. Sorry? Just mirror my laptop. Okay. Sorry for the technical difficulties. How? Yeah, mirror displays, got it. Okay, it's very high def. Thank you. I can't. Okay, thank you. All right, give me a minute to set up. See if this works. Odd. Continue. Yeah, you can see this. Okay. Cool. Test. Okay. So we're here to talk about JavaScript. I hope you're in the right session. I wore the shirt just to make it super clear. And we're here to talk about history. And I think it's really interesting if you peel it back. Like, what questions do I want to answer for you at the end of this session? Like a lot of common questions that I get when people are talking about their careers in JavaScript, because I help a lot of people with their coding careers. How do you deal with JavaScript fatigue? How do you know what technology to bet on? And also, more to the point, how do you know what to blog about? Which is something that I try to demonstrate with my own example, but even I struggle with as well. So I want to take that as the lens which I guide you through the rest of this discussion. So I hope you join this journey with me, and I promise you it will be worth it. I want to give you the bottom line up front, is that you should try to play long-term games with long-term people. That's a quote from Naval Ravikant, it's not mine, but I think you can see it when you apply it to technology, that it's technology that we've lived through, and it's actually really good for your career long-term. Okay, so like Eva mentioned, this talk actually started as a tweet. I tweeted this out, it just went crazy bananas, and that's when you know you have something on your hands, that you have really captured the momentum or the point in time that the people are really concerned with. And someone liked my tweet so much that they actually drew up my like a mock OG image or like a game title. I don't know. Apparently this is a very popular Lord of the Rings game. I only saw the movies. I never knew about this game, but it's really fitting. And I think that's one of the secrets of blogging, is that you really need to name things well. So it's not called one of the hard problems of computer science for a reason. Anyway, so the summary of JavaScript is really when I try to put everything on a single dimension, which is time. And I noticed that there were some patterns that were repeating, or some trends that were changing over time. And keep in mind, like, I wasn't there for a lot of this period. A lot of us were not. But I think if you can go back in time to study history, you can actually go forward in time to at least try to predict what might happen in the future. So that's kind of how I view this. Don't worry about the minor details. I'll actually go through a little bit of the first and second age of JavaScript. But the main thesis is really that every 10 years-ish, this is not like a strict rule or anything, but every around 10 years or so, there's a changing of the guard. There's some new emphasis in the development of what is going on with web development. And I think it's generational. Part of it is because like different people are just in charge now. Part of it is because the foundations are laid so you can do the next thing that is obvious, because you no longer have to worry about the core. And then there's a little bit of a pendulum back and forth in technology that you often see a lot. But I'll explain a little bit about my perspectives on those things. Okay, so what are we going to cover today? We're going to cover 5 elements. The first age, second age, we're going to split the third age into 2 parts, and then we'll talk about the death of JavaScript. Because nothing lasts forever, and JavaScript might go away someday. So we should talk about that. Okay, so talking about the first age of JavaScript, it's really about formation of the language. And that's something that is probably best expressed. I haven't seen it best expressed anywhere else except for this chart, which is in 1997, Brendan and I wrote JavaScript in 10 days. We formalized it in 1998. all the way to ECMAScript 3, and then there are 10 years we don't talk about, and then back to ECMAScript 5 and 6. And that was really the core of the language that we know and love today. And really, like, if you think about it, all the other development, all the other stuff could not happen if we didn't have this spec standardized. So I think it was very, very foundational. In between there, that really angsty period, we actually had 2 tracks of development, right? Like there was the dialect track where you basically want to fork JavaScript itself and like run it in your own proprietary runtime. That's what Microsoft and Adobe did. And then also there's the standard track where you try to stick to the standard JavaScript and then you try to modify it within its existing rules. And that's obviously, now we know that it won out with jQuery and the other tools. But it wasn't that obvious back then. And there was a serious challenge to the universal JavaScript that we know and love today. I think it really came together in sort of the darkest moments of humanity, which has happened during the financial crisis, but also in the darkest moment of JavaScript, when if basically the standards could not be harmonized, nothing could have come together, and JavaScript could have really seriously fallen apart back then. But I really encourage people who are interested in the history of JavaScript to check out this blog post by John Resig on the Oslo meeting that was held in 2008 that actually got the 2 sides of ECMAScript 3.1 and ECMAScript 4 to get together finally and agree on ECMAScript 5. And that was the foundation for the rest of JavaScript. The story is really well told in JavaScript the First 20 Years as well, by Brendan Eich and Alan Worsbrock. And I think it's just a really foundational thing that should be learned by every JavaScript engineer, because it really tells you a lot of the decisions that resulted in what we have today. So I'm really skipping through time a lot. If the first age was about establishing the language, the second age is very much establishing the ecosystem. Like the exact moment that we had a standardized base for what ES5 was going to look like, this happened in 2009. In the same exact year, CommonJS was standardized, ES5 was standardized, Node was introduced. That's Ryan Dahl introducing Node. This is the best picture I have, by the way, of that historical moment when Node was introduced. If anyone has a better shot, let me know, because this is terrible. And then NPM also was introduced the same year, even though Isaac insists that NPM does not stand for Node Package Manager. I have proof, if you go Google it, it's on the public Google groups, that it's actually NPM stands for Node Package Manager. All happened in the same year, miraculously after 2008 when ES5 was standardized. I wonder why. So there are 4 tracks, or 4 like sort of history threads that run through, and that was the color coding in the original graphic. So the first thread is developing the runtime of JavaScript, right? So when we're talking about forming the ecosystem in the second age of JavaScript, we're talking about the introduction of Node.js and Chrome in the same exact year in 2009, introduction of Electron, so extending JavaScript to the desktop in 2013, 2015, React Native and NativeScript, extending JavaScript to mobile apps. I probably should have put Cordova in there somewhere, but I don't actually know when it started, so it's very hard to date these things. And then Hermes, like the emergence of specialized JavaScript engines for a particular platform, I thought is a very, very interesting development from Facebook. So that's the first thread, which is runtimes. The second thread, build tools. We all know and love this stuff. Google Closure Compiler is still in use today. Surprisingly, the same age as again, like this 2009 year is very, very miraculous because so much innovation came out of it. And I think this concept of an annus mirabilis, like a year in which just a lot of stuff happens, is often the sign that something fundamental has shifted. And that's actually what happens for the third age, which we're going to talk about soon. But we have Grunt, Webpack, and TypeScript emerging in roughly the same year, Gulp and Tracer, and eventually replaced by Babel and Rollup. Okay, overall, like something that's happening, there's something that trended in the second age of JavaScript is also this trend of shift left in tooling, basically meaning that you try to shift your development and error discovery and typing and all that fun stuff left in your development phase so you can discover bugs earlier. I've given 2 other talks on this, so I don't want to waste your time. You can look up my talks on Svelte and the great space elevator, as well as growing a meta language, which is a discussion of React and TypeScript and what's happening with React and server components. Okay, so, and then the final piece of the ecosystem thread, we talked about the runtimes, we talked about the language, the build tools, we talked about frameworks now. development of, obviously we all love JavaScript frameworks, Angular, Backbone, Meteor, React, Vue, and Svelte. There's probably a lot more in here that I left out, but it doesn't matter. Like it's just an illustration of these are all the things, these are all the trends in user land development that were enabled by a really solid foundation that was established in the first age of JavaScript. So that brings us to today, the story so far, that we've done the first age, done the second age. What is this third age likely to be about? We obviously don't know. We're in the middle of it. But I think we have some really, really good hypotheses that I want to raise this to you because you may not have an overall organizing principle to understanding all this new development going on. So I'm going to give that to you. Basically, in short, RMRF legacy. First, we're going to talk about the assumptions that we're going to RMRF CommonJS, and then we're going to RimRef JS tooling. So we'll just talk about those two in turn. So the first part is replacing CommonJS modules for ES modules, which is the standardized module system. Gil actually, in a previous session, actually talked about ES modules and Node. I'm not going to waste time introducing ES modules to you, but except for I'm just going to recommend, for those who want a really solid foundation, now's a really good time to read up on the MDN docs as well as the V8 docs on ES modules to get a really solid foundation on what can and cannot be done with ES modules. There's also a community standard as to like what you can stick onto like the import.meta field, which is a weird, like dark place that you don't want to go into, but it's increasingly important as you try to build on top of these things. There are also important limitations of ES modules. Like we can't do ES module everything for several reasons. So one of them is the performance reason. That's way on the right. So this is from the V8 team saying that you should probably bundle still. You can't live in a future where all your web apps are just 100% ES modules. When someone visits your page, they just download 1,000 ES modules simultaneously. That's going to hurt your performance as much as HTTP2 is awesome. There are all these like local development options. There's like Snowpack and Vite and WMR that are really amazing, but only in development time. They don't actually help you at all in build time. And probably the biggest hurdle is the elephant in the room, i.e. 11. And that's really core to this thesis that like now is the time that we build on the ES module future because it's tied intrinsically to people being able to drop IE 11. So the picture I have on the right, on the left, is actually the most important picture to the death of IE 11, which is the US government's analytics dashboard. I think it's called analytics.gov or something like that. I can give you the URL later on. But basically, the US government has a rule that they need to support any browser with market share above 2%. As of November 2020, the browser share was 3.6%. 1 year later, today, it is 1.6%. So it's dropped a lot. And basically, whenever the US government officially drops IE, I think that will be a signal to the rest of corporate America and the rest of the world, to be honest, to drop IE as well. And I think that is really underway, and pretty much this is the year that it's going to happen. Of course, we already have proposals to drop IE 11 in Vue.js, Angular, and React. And then all these companies are also dropping IE, including Microsoft. So that's a really, really strong signal that this is the enabling factor for the ES module future that we really want. I'm also very encouraged by Edge, which actually rolled out IE compatibility mode, which I think is the ultimate sign that Microsoft is really committed to helping IE die a graceful death. Okay, in the browser, and in Node.js, we're actually seeing a lot of developer adoption successfully happening. So I've updated this chart since my original blog post. The usage of ES modules in the wild more than tripled in 2020. It went from 1% of all web page loads in Chrome to 3.7, 3.8%. And it's still trending up in 2021. So we've done a lot of good work here. Obviously, this is just initial load. So it's the moment you use any ES module import, this happens. But I think it's a very encouraging sign because this is a very big number of all, percentage of all Chrome loads. There's only so many percentages that we can really hope for because a lot of web pages will never be updated. On the Node side of things, a lot of maintainers are rewriting things to ES modules. So this is This is Sindre Soros, who maintains over 1,000 node packages, some of them extremely used everywhere. And he's saying he's just going to write ES module only from now on. So this is just going to trickle down very, very quickly now in everything else that we do. So I think we need to be ready for it. We need to notice that it's happening and understand its importance in our everyday development. So the second part of the third age of JavaScript thesis is that we're going to have new tooling, just a new base of tooling. We love not enough tooling, everything, just throw everything away. We need new ones. Why is that? I don't think people really like to throw away tooling that just works. If it ain't broken, you shouldn't want to fix it. But there are two assumptions that are essentially going away that are driving this. The first assumption is that we used to have this philosophy of for JavaScript by JavaScript. Like, if it's open source, JavaScript developers who use the tool need to be able to contribute to the tool. That is the assumption that is going away, that is no longer true. So the first very trivial way in which it's no longer true is that all the tooling now is written in TypeScript. It turns out that it's really easy to maintain. Here's a survey that I did, essentially capturing Next.js, React Router, Gatsby, Yarn, FBJest, Storybook, Apollo GraphQL. All of them are rewritten to a TypeScript core. So even I used to have this pushback. So I used to work at Netlify, and I used to propose like we should switch our tooling over to TypeScript. And the pushback used to be that it would increase the barrier of entry for people contributing, because now they have to learn TypeScript. That sentiment has done a complete 180, and now people won't use your tool if it's not built with TypeScript. So that's a really fundamental phenomenon. But a more drastic change is the adoption of systems languages for JavaScript tooling. So let's talk about Go. ESBuild is pretty much the most popular new compiler on the block. And it's up to 100 times. So these are build times. You can't even see the bar on the left, but it's up to 100 times faster than roll up a Webpack on their metrics, which are very artificial. But it gives you a sense of what's possible, and that's basically what Evan Wallace from Figma is trying to prove with ESBuild. It's a proof of existence of a better way. And now that the secret is out, now that the secret of the third age of JavaScript is out, everyone is doing this. So let's talk about Turbo Repo, which is being written by Jared Palmer from Formic. He's also this is monorepo tooling, so it's not that relevant to people who don't have monorepos. But again, it's the same idea. He started out writing this build tool in JavaScript, rewrote it in Go, and saw between 10 and 100 times faster speedups just by using a systems language. Probably there's also more optimization in that, so don't attribute everything to just rewrite it in Go and be magically faster. But it does make sense for a lot of hot paths to not be in JavaScript, because a lot of open source contributors will never touch it, and it runs in everyone's code. So you might want to optimize that in systems languages. Rust is the other really popular language, and probably it seems like it's actually winning over Go. So that's a controversial take there, but both of these are just like the obvious choices after writing in TypeScript. So these are the GitHub percentages. These are the percentage of language calculated by GitHub. Deno, Relay, and SWC have significant Rust percentages. Again, similar to the Turbo Repo story, Parcel rewrote its core in Rust as well on top of SWC, and is seeing similarly. I don't know what that's 10 times faster, so it's not 100 times, but it's significant, especially if you're running a build tool that you run 100 times a day. So this is just an inevitable part of our build systems now, that it's going to be polyglot. So kind of live with it. What is happening really? We're ditching the JavaScript core of all our tooling, and this is a movement that I like to call systems core and scripting shell. Like, most of us as users of these tools never really have to touch the core of it. So you should write that in a systems language that is as fast as possible. And you can use the scripting language as the shell that you integrate with for plugins and whatnot. And I think this makes a lot of sense. And essentially, this is the fundamental architecture of every tool that is going to exist to come out in the third age of JavaScript. So if you're building a new tool or if you're evaluating a new tool, these are the kind of things that you might want to look out for. The second assumption on the tooling side of things is this idea of a Unix philosophy. That is also going to go away. We used to have this idea that each tool should do one thing well. That seems like an obvious simplicity argument. The question is, like, what is the job? Like, when you say use the right tool for the job, we don't agree on what the job is, and the idea of what the job that we're doing changes. So my favorite example of this is word processors back in the 80s and 90s. This comes from a blog post from Benedict Evans, who is a really good essayist on technology, which I highly recommend. He used to talk about word processors. I'm going to have to read this from the screen because I can't really remember it. In the 1980s, if you installed a word processor or a spreadsheet program on your PC, they would not come with word counts, footnotes, or charts. You could not put a comment in a cell. You could not even print in landscape. Each of these things were separate products from separate companies that you have to go out and buy for $50 to $100 each. So imagine if each of these features were plugins, right? But as time goes on, as our understanding of what a word processor should do, it's just all built in, right? Can you imagine a system today where you have to buy one of these features to plug it in? No, you just would not use it. You would just use something that just had the bundle of everything that you think the job of a word processor does. So as we mature in our understanding of tooling, the job that it does changes as well. And we understand the standard feature set that everything should have. So it should not be so minimalist, and it should do more things because we use all these features on a day-to-day basis. So similarly, why are all these things different? Why are they all maintained by different maintainers? Why are there plugin files that connects my ESLint to my TypeScript, to my Prettier, to my testing? Why do I have 20 different config files that patch all these different differences? And why are they rerun in different ASTs on multiple times? The quote I really like on this is actually from Ellen Perlis. This came out in 1950 or something like that. Really, really old logic that we have kind of ignored and failed to pass on. It's better to have 100 functions operate on one data structure than 10 functions on 10 data structures. And that's essentially what we have here. Each of these things have different representations of their code, and they're run at different stages in time. A lot of the speed up of ESBuild versus Webpack is actually not to do with the language difference. It's actually to do with minimizing the number of EST runs that are done in the build steps. And we are coming to understand that we should do as much of this job in one run with the single AST as much as possible because they are the same job. And that's something that's happening right now. Previously, in the second age of JavaScript, the way that we dealt with this is we swept it under a rug. We say, all right, there are too many dependencies, we'll bundle it under one dependency, problem solved, right? And that was problem solved in the second age of JavaScript. In the third age of JavaScript, this is no longer good enough. We need to fundamentally solve or eliminate the problem, as Ken C. Dodds would say, instead of just trying to fix problem after problem with more and more band-aids. So these are more examples as well. So I have a name for all these these systems that we build on top of all these tool sets. So Create React App solved a lot of configuration problems by sweeping under a rug. But then we also did that for routing. We did that for components. We did that for servers. So Gatsby, Next.js, Blitz.js, Redwood.js, they're all subsets of this overall, we stitch things together for you as a service phenomenon. That flies in the second age of JavaScript, but no longer in the third age. So what does that really look like? Is we're actually going to collapse layers. I have a separate blog post about this. A lot of these things are individual blog posts that I've just kind of stitched together for this talk, so you can follow it up if you're really interested in these ideas. So instead of having them in sort of combined dependencies, we're actually going to collapse the layers fundamentally by re-architecting the core tooling that drives all these things. So on the left, is a picture of the Rome's pitch deck. Rome is a company. So this is actually what they pitched to VCs, that this is the problem and this is what Rome is going to fix. On the right, this is the docs page of Deno, and the same thing. They have on the same page a formatter, a linter, a prettier tool, and a test tool. And this is all part of a single binary that just does so much more for you than Node does. And this is just, I think, going to be a required part of any tooling that you adopt in the third age of JavaScript. So I think a very, very fundamental, it's almost weird because the layers that you use are going to get more complex in order to make your life simpler. And I think that's a difficult trade-off. There are definitely going to be cases where this trade-off does not make sense. So I am not saying that this is going to be applicable for everybody. But I do think that this is the future, at least for now, at least from what we're seeing for all the trends. And it makes so much sense compared to all the stuff that we saw in the previous 2 ages. The other thing that is really, I guess, heartwarming / worrying is that the venture capitalists are coming for the third age of JavaScript. So no longer are we begging for donations on Patreon. No longer are we begging for donations on GitHub sponsorships. Venture capitalists are actually coming in just funding this. So you're going to get really great software written on VC tooling, and that may or may not work. It remains to be seen. But these 2 companies, Deno and Rome, are both funded to provide this as a service for us. So we'll see where that takes us. I'm a little bit cautious, but at least it's a different approach. It's a new approach to the funding model that we've seen in the second age of JavaScript, and I think that's a positive. Okay, no futuristic talk about JavaScript should end without a discussion about the possible death of JavaScript. I don't think that JavaScript will last forever, despite it having lasted as long as it has. And I think a lot of inspiration I draw from Gary Bernhardt's talk on the birth and death of JavaScript, or JavaScript as he calls it. And he basically predicted the arrival of WebAssembly. And that's something that Brendan Eich has also started talking about as well. He used to say that you should always bet on JavaScript. Now he kind of hedges and says you should always bet on JavaScript and WebAssembly. And I think that's entirely possible. So Gary Bernhardt gave us a timeline of 2035 that JavaScript will kind of end, together with the possible nuking of California, which I'm a little bit worried about. But it's still we should still think about, like, is this the best ultimate end state of, if we could redesign everything from scratch, is this the best ultimate end state? Probably not. Probably the third age is a consolidation stage from the first and second ages. So that's where we are at. I just brought you on a lightning tour of the history of JavaScript. The way I see this, why is it important to have a historical view of JavaScript? And that's mainly because I want you to play long-term games with long-term people. I think that this is how you avoid JavaScript fatigue, by understanding the long arcs in history and where you fit in the overall picture. Like, when you look back in the 10 years from now, what will have been the obvious trends? I think constantly taking a scientist mindset to saying, having a hypothesis on what is happening and what will happen, testing it out, blogging about it, getting feedback, and then iterating on that. I think that is the way that I handle JavaScript fatigue. I understand and get close to the projects that are going to matter in the future, and I highly encourage that approach for you, not just in JavaScript, but in a lot of aspects of your life and career as well. So if you're interested in more on this stuff, you can read up on my blog posts, swix.io/JS Third Age. And if you're interested in applying this to your career, I also wrote a book about this called learninginpublic.org. And yeah, happy to take questions after this, but thank you so much. Your mic is not on.
Yeah. La, 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 la. Let's give it up for Swix once again.
Thanks, everyone.
Yeah.